Great. So now, being in week 5, we're up to our project 2. So we're still finalising our project 1 for planning, but also it's time to get both you Ryan and Mary started on the building approval side of things as well. Have either of you had a look at that yet, at the building approval subject? So you'll see that what it means is there's each week that the two of you will end up having more work to do than James and Conquer, because we're progressing through the planning at the same sort of pace for the rest of this, but then for the building approval you're going to have to do a little bit more work. But the two of you, I also notice you tend to look at many of the building approval aspects as you're going through anyhow, and there's a lot of commonality between the stuff you have to do for the building approval and the planning approval, so it shouldn't be too much more work for you. I'd say maybe an extra hour a week for doing that, although don't hold me to that. So you've got to get started on that, and I'll I should take you through that today, but I can do that because Emily and Isaac are already progressing through, so they don't need an introduction to that, so I can take you through that today as well. But what we do need to get started on is that project 2 for planning, and so Conway, you've got to finish that project 1, same as James. So I'm recording this session. You can have a look at this later on, but you get an introduction to it today, and then you'll get started on it probably next week or so, just 1 week after Mary and Ryan. So what we have, once again, we've got a procedure document for it, which many of these things should be fairly familiar to, and then some aspects which aren't. So the client brief is: the client requires the apartment block to be converted to allow for disability access to the upper floor and a disability access apartment created by converting 2 apartments into 1 apartment. So we have an apartment block, and it's an existing apartment block. They need to do some demolition and some changes to allow that disability access to the first floor, and then also change 1 apartment to make that apartment accessible for those with a disability. And also so what we have here, this is not a perfect real life scenario, in that as what has already been identified is that the shape of the allotment does not match the shape of the allotment in real life. What you're required to do in that sense is just take the Revit model that gives you the dimensions of your land, your allotment, the placement of the building on your allotment. That's the allotment that you're dealing with. You simply have the address, and from that address you can also look at what the neighbouring buildings are, how far they are set apart from the boundary, and impose those into your scenario for the location of the structures at the side. Beyond that, it's only the information for planning, etc., that you have to gain for that site. Also, in regards to planning for that site, I've been given the planning documents for you to fill out, and I'll put those on Learn, so you can do those without having to go online to get those from the council, because the way that these ones are set up with this council are that you have to fill them out, and you fill them out page by page by page, and there's an issue there that you may end up lodging those documents. So
I did that.
Yeah. And that's all well and good. It takes somebody to go sort of shoot ahead and scout for problems. So I appreciate that. So those will go up onto Learn. Also, So you're going to have to reference AS 1428.1 to focus on door widths, access from lift, bathroom size, and layout. So also attached. Oh, and I'd like to make a note. This is actually, of the things you could focus on for TAFE, this might be actually a really good thing to get your head around thoroughly, because there is a lot of work in this aspect. I've mentioned that about building bushfire-prone areas as well. There are not a lot of people who are working consultants in that field, but this is another one. And with a lot of my work for engineering, for repair and reinstatement of buildings, there was actually quite a lot of retrofitting of buildings for accessible ramps and updating of bathrooms to make those bathrooms accessible as well. And given our demographic in South Australia, that we have an older demographic, if you look at our demographic models, it's very top heavy, and that's continuing to become more and more and more. And I can't remember the stats directly off the top of my head, but I think it's in 2050 there's I don't know, but basically the proportion of elderly people to young people is going to be massively skewed, in those coming decades. So I think this is an area where if you appreciate this work, if you're good at this work, there'll be plenty of work for you, because it's not a aspect of the industry which is going away.
Gave my son's high school 10 million to make it all disability accessible.
Yeah.
One student.
Yeah.
That's for one student.
Yeah. But that's one student today.
Yeah.
But
I
then
think they're planning on getting more in.
Yeah.
The first thing they did up though was the teachers' lounge.
Right.
Yeah, that's the first place the 10 million went to.
Yeah. And so but this as an industry is not going away, and like you're saying, there's certainly money and allocation of funds for it. Also, beyond that, in the absence of the client, an air conditioning system, so I'll impose that word system here into this sentence, has recently been installed. However, your client is unsure of its position or output. So basically, you're asked to come up with an air conditioning system that you think is appropriate for that building and put it in there and specify what it is. So you give that information back to your client.
So we can be fictitious with that?
You can be fictitious with that. Yeah.
So are we to assume that it's got, because we're going to have to do details and sections, what do we do in regards to the ceiling? Because there's no ceiling in it. Are we supposed to just assume that it's a hanging drop ceiling, or?
Yes.
Yep. Okay.
How much plenum space have we got? We've got a fair bit of plenum space, don't we? Like, is it like 450?
Yeah, it's massive space up to the roof.
Yeah. Right. Okay.
So you could definitely, it would be a hung ceiling. So.
Yes. Yeah. So go with that. And so do you know what the plenum space is?
I'll find out for you. I'm on it now.
Yeah. Yeah. And so there's that possibility of a ducted system. However, if you think about that, does a ducted system work very well with single occupancy units? I'd suggest not. And with the cost of your other small reverse cycle split system units.
And then who pays for it too if it's all one system?
Exactly. Yeah. So you've got to think about what air conditioning system is appropriate for that building, and include that information within your plans, or as an appendice to your plans. And then also the lower level garage is to be enclosed on two sides and adequate parking for residents. So it says in here, development plan allowing for disability parking, so AS 1428.1, and visitor parking, so from the development plan, to be designated on plans. So one of the first things I'd be thinking about here is, okay, so we've got to look at, we've got to work out, okay, what council area is it in? What aspect of their development plan is going to relate to car parking? Is it going to be their council-wide objectives, or is it going to be the zone-specific Can I get any suggestions on that? Where you think we would find information on car parking?
Well, the NCC specifies that there has to be, like for normal residential, 2 parks for every house that's above 2 bedrooms. So does that comply to a building if there's 2 bedrooms in each apartment? Does that mean there's supposed to be 2 parks per building, per apartment?
Well, it does, because the NCC overrides everything. So, so when I say it overrides everything. What if we have a development plan that says you need to have X? Let's say we've got a development plan that says you need to have 3 car parks, and then we have the National Construction Code that says you need to have at least 2 car parks. How many car parks do we need?
Well, in that case, you'd follow the councils because it's more than the NCC.
Exactly.
But if the NCC is more, then you go by that.
Yeah, exactly. Yeah. And so if the NCC is saying we need 2 and the council says we only need 1, well then yes, then we have to go with the NCC. First place I'd be looking though is the council. So what does the council say you have to do? And then also, because with this project, this one is set out the same way as project 1, which is in that fashion that we've got to do some research about that property and its council and its zoning, etc. first. So we go there, we have a look, and so actually possibly I'll have a quick look, see if I can, because I've got Revit on this computer, I'll bring up that Revit model on this as well. So project 2 Revit file, open that. So we're going to have to refer to AS 1428.1. But first before we get to that, so this is the building. This is our 2-story building with the units above. And we have to enclose that bottom section on 2 sides to create a sheltered car parking space underneath. So that will mean that there's some change to this honeycomb aspect here at the front. So much like project 1. Confirmed dimensions, materials, conformity of information stated on specifications and reports to compliance and client requirements. So you're going to have to look at what the building is made of and whether that complies and suits the client's requirements. Developed existing class 2 accommodation model to meet requirements of your site analysis, notifications, material selection, demolition. So you're going to have to do a demolition plan for this one, because there's going to be aspects that are changed about the building, and then include in there your modifications, so access via stairs and lift to upper level. So within and I'll see if our Revit model is working now. Yep, so we've got our Revit model there. So let's have a look. Site. So we're given this site. We have some crossover. We have some cutouts here for crossovers. So this is the site as it exists now. Okay, Green Trees Road, that'll have to be changed to Kincaid Road. And if we actually look at number 3 Kincaid Road in Henley Beach, that site does not exactly match. Please ignore that. And this is the site that we're dealing with our site dimensions as we have it, and this is the location of our building on the site as set out. Also, in regards to our demolition, if we've got a location of a lift here already, but we can demolish that and we can move things in that regard if we want to make better space.
Do you know how to do phasing?
No, what is
Revit?
phasing? No,
That's
no.
how you do a demolition plan.
Right, okay.
If you scroll down on your properties to the left, scroll right down to the bottom,
Phase.
phasing. So
Yep.
you'll have to duplicate each drawing that you want to do demo on, label it as demo, and then your phasing, if you click on those things, it'll say like demo, show all, so past, present,
Yes.
future,
Yeah.
like new, future,
Yeah.
demo, past, or existing, it's all in there.
And that's how you do the.
That's how you do demo plans. Otherwise, what you demo, it'll fuck up.
Yes, it'll take out in other. Yep. Also in relation to these plans, so we've got we've got ground level here. We've got some columns located in here. I suggest we don't go trying to move any columns and muck around with that. I think if you are going to be retrofitting a building, that's probably one of the last things you'd want to touch. But certainly that's still within the realms of possibility. But I suggest you should avoid that.
What's the square on the centre?
That's the air conditioner.
Right.
Okay,
Yeah.
so that's on the roof,
No, that's on the ground.
that's on the ground, okay.
Yes.
Yeah.
That's
Yeah,
on the
So it's
ground
in the
level.
basement on the ground,
On the ground. There's no basement, there's no elevator pit, there's nothing on the ground. There should be an elevator in that picture.
Yeah. So I suggest removing that air conditioner, or well,
just-
move that air conditioner to where you want.
Yeah,
Also-
what I did was I just deleted it
Yeah.
until I'm up to moving the air conditioner. It's still in your components. You just go to your component, load it back in.
Yeah. So and then because we've got our lift here on level 1, but we don't have it on our ground floor, and we don't have any penetrations through the floor. Move that lift to where you think that works. I suggest it works somewhere in this side here, anyhow, but it may not work exactly in the situation that it is. So that's our site, and have a look at section 1, where we don't have any other sections.
It gives you, when you do a Revit, it comes up with a section like from the get-go, no matter where you go into a drawing.
Right.
I normally just delete it away. It's like
Okay.
a default setting at the start of the drawing, yeah.
so what is
Yeah.
that honeycomb?
So that's
Got to be removed.
so that's an architectural feature.
Okay,
So
but
yeah.
it's
So
showing
it's-
it around the other side that looks really low, like,
Yeah,
It
you,
is-
you can't drive under it.
you
Yeah.
can't drive
So
under,
you
you
have to-
can't
you
drive through
demolish
it. Yeah.
yeah,
Yeah.
okay.
And I might suggest that's a fairly outdated sort of architectural feature anyhow. I would, if I was retrofitting this building, I probably wouldn't be too attached to that.
Someone bothered to sit there and draw that.
Yeah.
Just
Mm.
random.
And so so we have that, certainly have that to deal with. And so here's our air conditioner here again. Probably want to be moving that. So addition of two-sided enclosed Class 10 garage under accommodation. So we're going to have to look at. So actually, we'll go to our ground level here. So we're going to have to enclose two sides of this, or at least two sides. And then so we've got to think about access and egress, provision for services, and then how that relates to the development plan. And we do the same sort of stages with our task 1 and task 2 of desktop research with this one as we did with the first project. So this is all fairly familiar. Develop sheets to meet requirements for planning approval. Cover sheet, 3D view of premises, client name, contact details, project type, student details, etc. Site analysis plan. Neighbouring structures. So impose those neighbouring structures on this scenario. Services, vegetation, fence, shadows. Do a site plan dimensioned with a north indicator. Contours. So we have an incredibly level site. We don't have any contours to worry about with this one. Dimensioned site setbacks. So that's an important thing. We rely on the Revit model as we're given for our site setbacks, and there may well be some conflicts there with council in regards to that. But remember, we have an existing building, and this is an existing building to be retrofitted. It's not a building that we're putting in a planning application to have built, but we're putting in an application to have it modified. So north indicator accurately placed on the plan. Site access and egress from roadside and around site. So proposed garage plan layout. So when we say garage plan, that's the Undercroft car parking. So that first level car parking or ground floor car parking. Floor plan fully dimensioned, north indicator, total floor area, etc. Overall dimensions, wall openings for external doors and windows, rooms and wall thicknesses, internal rooms and wall thicknesses, door clearances. So in regards to our wall thicknesses, so these are the walls that we are given. Now, yes, it is a bit odd that we have brick veneer walls as dividing walls. Take those walls as a width of a wall. So it's structural stud walling. So studs provide the structure as they do in a brick veneer.
So they're not existing firewalls. We would need to, if they're not existing firewalls, we would need to change that.
Yes. So we don't have any information on them on whether they're existing firewalls or not. So we'll have to assume that they're not.
They appear to be double width.
My question.
But yes.
Yeah. There's no double brick in there.
No, they appear to be double width, which means they could be firewalls.
My question is, the wall he wants to demolish in between the units.
Mm-hmm.
Before we can demolish a wall, you'd have to get an engineering, because I would assume that is structural. Because there's no columns going up to hold up the roof. All the columns are doing is holding up the floor. So
those columns don't follow right through?
No.
Yep.
So to me, this wall here. Oh, sorry, he's taking it away.
Oh, I'm sorry. Sorry.
These walls here are structural. Depending on what the roof, we've got no information in regards to the roof. So if you want to remove a wall, we can't just say, oh, we'll remove that wall. You're going to have to get an engineering to tell you, yes, you can remove it, or no, you can't.
Can we see the plan with the columns again?
Okay. Yeah. So that's our north elevation, is it? Or no, our ground level. So our ground level has columns.
They probably are going all the way through to the roof.
But they're not drawn that way. They're not there.
They don't
go through to the roof. No, they're just up to the concrete floor.
They're just supporting the suspended floor, you're saying?
Yeah. So, yeah.
Although,
they would comply.
Yeah.
They look like they comply.
Well, what we do have happening.
Correspond,
They do appear to correspond. So we've got so these are our grid lines, and those grid lines are going to stay the same through our building.
Yeah.
So if we look at our ground level, we have columns here going. So column going through each of those grid lines, and A1, we have a column there. So let's look at B3. So we have a column here at B3, then one at B4.
So
if
I'm
we,
pretty sure they go right through.
So
it'll be on C.
So if we've got B3, we've got a column heading through this junction here. Now it's not shown. It's not drawn.
So would that not mean that that's a structural wall? It would it not? That they've gotten rid of the columns gone all the way through and put in a structural wall.
Yeah.
It's just that's been shown on the
But
page,
yeah.
So yeah.
Yes, okay. That is a really good point.
I mean, if
but
the roof is of a lightweight construction, maybe you could get away with getting rid of a thing, but you'd need an engineer to say, listen, there's a beam in here at 2100 high. You can knock out all this brickwork and stud work up to that height. That's fine, but without that information, don't just go in knocking out walls.
I would assume, because we can just remove the elevator, we can assume that those columns go right through.
Yeah. Well, look. Yeah. I'll take a punt and say let's assume the columns go right through. So
that's all right. No worries. It's just when you start to use the demolition tool, once you've demolished something, it's not easy to get it back.
Yes.
It's not just a matter of you've got to go into your phasing and it's past. And,
yes.
You know.
Yeah. I understand.
It can get confusing. So just be careful when you start to knock shit down.
Yes. Oh, definitely.
And in the real world, yes.
In the real world, yes. So let's. I think given that we have a structural grid here on this plan, that structural grid carries through. So
that would be normally how they do it. If there is a structural grid,
yes,
that normally is followed through on all the floors.
Yeah. So where we have these intersections, so like B2 for example, will have a column in there, and B1 will have a column in there. You would not want to touch those aspects. So basically, wherever we have a junction of a number and a letter on our grid, you would not want to touch those aspects. So if we're demolishing a wall, I suggest yes, you can demolish this wall here without having any structural impact. However, you cannot demolish this section here without having structural impact. Yeah, we'll just go with that. But thanks for bringing that up. So with our walls, let's assume that we can meet those FRLs, that we've got plenty of wall thickness there, accommodation for that. We can meet those FRLs. So select appropriate standardized windows and doors, etc. Produce 4 elevations. Produce 2 sections. All aspects to be supported on detail sheets from reports provided and or reference from the National Construction Code and Australian standards, including relevant specific clauses. It says here longitudinal through bathroom, shower floor trap, stairs and lift. In regards to the lift, what you're required to do is go online and choose a lift. So Ryan went to the Cone website and said the Cone website is really good. There's also JPS lifts as well. So two major lift manufacturers here in Adelaide, or lift suppliers. So have a look at those lifts and decide on which model you go with for this project, and then you'll get your dimensions from.
Also found when you do you go to do your kitchen in your disabled access apartment, on the SA Gov website, if you look up accessible kitchens, comes up with a whole heap of information in regards to designing an accessible kitchen.
Okay.
Like preferred heights for bench tops and all that sort of stuff. Like for instance, you wouldn't think of it, but no cabinets under sinks.
Yes.
And kickers have to be sort of 190 high and 190 back to allow for the feet to go underneath them and all that sort of stuff.
So SA Gov accessible kitchens.
Yeah.
I might put that link on Learn. So the cross section through bathroom, shower, floor trap, stairs and lift. So we've got our lift there. So that means we're going to have to. Well, we're going to have to, for this project, design stairs anyhow. So we'll go through the National Construction Code and the limitations on the design of stairs. We'll have to show roof structure, wall structure and floor structure. But also within this section up the top here, we've got shower floor trap. as well. So within your disabled bathroom design, as set out by the National Construction Code, there are limitations there with, how do I say it, and we'll go through this, about sharing spaces for access. So sharing those spaces within the bathroom for toilet and shower, etc. So it's about using a shower curtain so that shower curtain can be drawn back and you can use that space to access the toilet, be most efficient with your bathroom layout. But then there are floor slope relationships that have to be adhered to for that. And then also cross section through the balcony, window, and once again wet area. The internal materials clearly labelled. For example, if cladding is selected, what kind of cladding, what render, and what colour. So the council are going to want to know those things. Detail all aspects to be supported on detail sheets from reports provided and or reference to the National Construction Code and Australian standards. For wet areas, what your wall linings are going to be, wall and floor, water resistance, waterproofing requirements, type, and heights. So we'll run through waterproofing requirements, not in today's session, but in next week. Screed gradient of floor and floor set down. So we're going to have to be working through that to work out what sort of set down we need to achieve what floor gradient. So given that we have an existing slab, that might mean jackhammering up some sections to create a set down. Installation of puddle flange. So does everybody know what a puddle flange is?
Yep.
Yes? No? No. So that's in regards to getting, it's a design feature to help get rid of moisture from underneath the tile screed. So we'll go through installation of puddle flanges. So that's basically the standard way a floor trap is done in Australia, and that differs from America, by the way.
So how do we? Thing is, how do you draw that in?
You just note it in your notes.
Okay.
Yeah, but if you're doing a section through your wet area, you can show that in, and you can show it as a detail.
Okay.
As well. Yeah, so you can cut through. So that's going to look like. That's my gradient, and then that's my concrete, my screed, and my puddle flange is going to sit here like this.
Oh, yep. I see what you're saying.
That sort of thing, and then we go, okay, waterproofing overlap. Actually, no, waterproofing overlap.
And they're rubber, yeah? Are they rubber?
No.
Plastic.
Plastic.
They're the same as the plumbing pipe.
Yep.
Yeah. Yeah. So you're gonna draw that.
And that sits underneath the screen.
Yes.
Okay.
Yeah. So any of the water that gets through the screen goes in there as well. And then cross-section of stairs with compliant aspects to be clearly portrayed and supported by specific clauses from National Construction Code, regards to goings, rises, width of stairs, heights of railings. And then lift, cross-section of lift with compliant aspects to be clearly portrayed and supported by specific clauses from NCC, regards lift type, width, height, lift clearance, button heights, door widths, access. So a lot of that you may actually get from your lift manufacturer already, because they are going to manufacture and supply lifts that correspond with this. So you may be able to save yourself a lot of time in that regard by doing good research in regards to the details that you can get from your lift supplier. 3D view to external, minimum 4 internal, depicting aspects essential for build. A door and window schedule, appropriate label of doors and windows, any key requirements set out by local council, and then submit for approval council development plan requirements, completed required application forms including power line notification. So we should all be fairly familiar with that. copy of council requirements, so fees from the website, copy of council requirements for notification if required, PDF of sheets required with attached product specification, so in regards to your lifts, and air conditioning, and then of course seek feedback and make modifications requested within required time frame. So that's about the peer checking, etc. So much of that should be familiar, but aspects that aren't are things like design of stairs, access, disability access, design of car parking for underneath, and then also some of the cross-section stuff like our design of our bathrooms, and showing those aspects.
Yeah, I've got a
Yep.
question.
Yep.
As the floor goes under the whole building, obviously like it goes external brickwork to external brickwork.
Mm-hmm.
When you cut a hole in it for your shaft, because you need to do an elevator shaft,
Yeah.
isn't that going to leave a bit of floor just sort of hanging there in the middle of nowhere?
Yeah. So the way you'd end up supporting that with some I-beams. So you'd run, yeah. So you'd run. So from your columns, you'd have to make up. And look, I'm not, I don't want to go engineering these things on the fly, but what I would initially start looking at is, if this is my building here like that, I'm cutting this hole in the floor there like that, but I've got, column here, there like that. I'd end up I-beam, or there's probably some sort of structural support like that, and then producing a lattice like that, and I'd probably have to have some sort of I-beam support there. Depends on whether it's a one-way slab or a two-way slab, and that you'd know all about. Yeah. So it's about providing that structure underneath that cutout to support those sections. So and look, and we're not, we are not going to go sizing up I-beams to make a structural section underneath, but you can include some indication of that on your plans if you wish. You can say supporting structure underneath to engineers details, but it's certainly possible. Right. So going back to learn. So as with our first project, with this project we have task 1 project requirements, task 2 desktop research, and then we're on to client consultation, and then report request. So the same as our initial project. So within our project requirements, that should be fairly familiar. I'll just bring up student practical assessment. So on Salus, so property location, locate council zone, property location zone, wind category, energy efficiency, climate zone, locating council website, locating and completing planning approval application forms. So I'll provide those to you, and I'll do that today, so we can get started on this one straight away. Locating and completing power line notification form, etc. All of those aspects should be very, very familiar to you, and so we won't need to go through that again, unless there was anything that you guys needed rehashed in regards to that. No. Okay. And then once again we have our desktop research to follow that, which is going to be fairly similar. Following on from that, we have an information sheet here. Well, it's a URL that takes us to a summary for accessible disabled car parking requirements. So once we have established with the council and the National Construction Code how many car parks we're required to have for this building, that's probably where I'd that's probably where I'd start, is thinking about my car parks, thinking, okay, this is how much space I have to allow for my car parks, this is how much room it leaves me in various aspects. And so we need to think about our car park design. So we'll need to work through this. AS 2890.6 off-street parking for people with disabilities, and then also AS 1428, so means to assist orientation of people with vision impairment, tactile ground surface indicators, etc., and general requirements for access new building works. So AS 1428 we're going to have to look at for accessibility, and 2890 for car park requirements. And so it gives a summary of the key requirements for the disabled park. So angled parking spaces are to be 2400 wide by 5400 long. However, they need a dedicated shared area, or actually possibly this is better for me to show within the code. Well, I can run through this just quickly, picking out some key aspects for that, but then we'll have a look at the code. Okay. So yes, yeah.
Something that's not really is to do with what you were saying to me before about clearance space.
In regards to just
Well, this is the bathroom here. Would that be coming from straight on, or would that be classed as coming from that direction?
It's about the distance between your door and the shower there as to whether it's approach.
So that's from the far tip.
No. So take your dimension from this wall here through to your shower, or whatever, 8 and 8.5. So you can that could be a front approach. So if we're doing angled parking, so 45 or 90 degree angled parking, we're at that 2400 wide by 5400 long. However, parallel parking spaces are to be no less than 3200 wide and 7800 long. Headroom above each accessible parking space and adjacent shared areas to be minimum of 2500. I don't think we're going to have an issue with that with this building, but have a look. Yeah, but what we'll have to show though in the code is dedicated space and shared area. So we'll go to that now. So we'll have to have a look at that site and think about what sort of parking we're going to have, whether it's going to be parallel parking or angled parking. Having a look at our angled parking, we have, and there are differences for Australia and New Zealand. So also be aware of what's so do your requirements as per Australia. We're having to have a dedicated parking space of 2400 wide by 5400 long, as it said in that summary sheet. But then we are to have shared area of 2400 long by 2400 wide at the front of that parking space, and then another shared area at the side of 2400 wide by 5400 long. So that shared area, that could be shared with another disabled car park, or you can have that area that's designated as, say for example, area that's shared with access path to lifts or stairs or something like that. What we can't go doing is saying that's another car park. So we can't go parking cars in here. We can't put any permanent structures in here. So that's a space.
Could you use that shared space as like motorway?
No, so you
No?
can't. No,
No,
so it's
okay.
so it's no other parking, and it's no other obstructions, but so it's clear space, but it's not dedicated clear space. So it's clear space that can be used by other people using that clear space
Because
as
that
well.
got changed. It used to be different than that,
Right. Okay.
with disability parking.
Right. What was
It used
the?
to be 3,600 for a disability park,
Yeah.
standalone.
Yes. Yeah.
Now they've decided, no, we'll do 24 with this shared space
Yeah.
between two parks. And so they can have a disability park as long as there's a shared space there and a shared space there.
Yes. Yeah.
Yeah.
Yeah. And so this shared area that can sit between two disability parks, which what was the old measure? 3,600 was it?
3,600 for a
So
disability park.
yeah, so 3,600 for two disability parks right next to each other. We have 7.2
Which is
meters.
tough.
Yeah, or 3 lots of 2,400 is
Yeah.
7.2 meters.
It makes it hard
it's-
though, because
yeah.
if you've only got one disability park required,
Yeah.
can you go with the old 3,600, or do you have to go by
No,
that?
so you got to go by
That's the new
this.
standard now, so it's actually
it's-
more.
Yes.
Takes up more space.
Yeah. So that's for our angle, and here is an example of that. So that's our 2400 wide, and then here's our 2400 shared area. In New Zealand, bollard is not required. In Australia, bollard is required to stop other vehicles parking in there. So you need to show that on your plan, and that's the other scenario there. So that's for parallel parks, and that's fairly. That's for angle parking. That's fairly simple. Parallel parking, you have to give more space. So in Australia, at least 3,200 wide by 7,800 long. Then with that, you also have a shared area, so a clear area for movement and access of how wide is that? 1,600 wide in Australia by 7,800 long. So then for any parallel parks in our plan, we've got to accommodate for 4,800 wide by 7,800 long. Is the amount of space we'll require for that. Ramps are probably not going to be an issue in our project, but do be aware that there are limitations on the slope relationships of ramps and access to ramps. And clear space is probably not going to be an issue for us, but be aware that there are requirements around clearance for disabled parking as well, so for height clearance. Just quickly, also in regards to ramps, so you have your general access ramps that have a slope relationship, and they have a maximum of how long they can be, but there are also curb ramps as well. So small, short sections of ramp to take you up onto a curb, and there are limitations on design for that as well. So each dedicated space shall be identified by means of a white symbol of access. No, where's yeah, thought I'd find our slope relationship of curb ramps just there. So where curb ramps are to be provided, they should be placed at the front or rear corner of the parking space. Details of curb ramps are given in AS 1428.1, so we have to refer to AS 1428.1. So those are our space requirements for a disabled car park, and you'd start with that. Then at that same time, you should be looking at the space requirements for car parks in general, for your off-street parking. And so I'll just, so where we're going to go to for here, design of parking modules. We've got page 13 through to 27. So, angle parking spaces in Australia, 2.3 metres wide by 5 metres long. You're also required to have aisle width at the back. So, so we've got our so yeah, so there's the tables, and thanks Mary for helping clarify that. So our width of our bays. So probably we're going to be looking at bays at 90 degrees. So for our class 2 bay widths of 2.5, and then where parking is to a wall or high curb, not allowing any overhang, we'll have to have aisle width at the rear of 5.4. However, where parking is to a low curb, which allows 600 overhang in accordance with 2.41a, we're looking at C2. So our aisle width behind of 4.8 metres.
No, that's the length of the park.
Oh, the length, yeah.
So that's the length of the actual parking
length
space.
of the park, yeah, and then our aisle width, yeah.
So there has to be
5.8
5.8 metres behind those parks,
yeah,
for reversing out.
yeah, yeah. Sorry, yeah. So the length of our park in that scenario where we can have overhang 4.8, and then and then aisle width is here. So so be aware of those for the angle parking. And so that was angle parking, and then for parallel parking on page 18, there's the lengths and widths of your for your parallel parking. So so work through that and design your car parks in accordance with those. Then the next thing we need to look at. So once we've got our car park design done, and thinking about the spaces that are required for that, then we have to look into disabled access. So first of all, so we go through to access and egress. Well, actually, before we get into disabled access, we're going to have to provide provision for escape on this property. And so the first place to look is exit travel distances. So we determine what class of building we are now. With a multi-residential property, we're going to be looking at a class 2 building. The entrance doorway of any sole occupancy unit must be not more than 6 metres from an exit or from a point from which travel in different directions to 2 exits is available, or 20 metres from a single exit serving the story at the level of egress to a road or open space. So what that means, and so no point on the floor of a room which is not in a sole occupancy unit must be more than 20 metres from an exit or from a point at which travel in different directions to 2 exits is available. What that means is the 20 metres from a single exit serving the story at the level of egress to a road or open space. That means that once we're on our ground level, so that's our level 1, from our ground level, that relates to the exit from the building at ground level. We can't be more than 20 metres from, we'll go back up to level 1. If let's say for example we put a staircase in here, then it can't be more than 20 metres to go from here down through that staircase and to exit from level 1. Wrong one. Or 6 metres from an exit from a point from which travel in 2 different directions to 2 exits is available. So then, So basically, what this is telling us is that we are requiring to have 2 exits to this building, being a Class 2 building. Going further on with access, we'll have to consider, and this is something that Ryan brought up this morning, for general building access requirements for access for disability. Buildings and parts of buildings must be accessible as required by table D 3.1 unless exempted by D 3.4. So let's quickly have a look at D 3.4, see if we have an exemption. The following areas are not required to be accessible. An area where access would be inappropriate because of the particular purpose for which the area is used. So any ideas on inappropriate areas to access in a building?
Stairs.
Yep. Yep, that is a really good one. Yep, stairs. So yeah, so disabled access, not going to be using stairs. Yeah, other things might be storeroom also. But yeah, I think that is the most important one.
And it would be accessing a lot of fire. Here as well.
Yes, yeah, not going to be accessing electrical panels. Anything that has to do with building maintenance and specific uses of that building that are not normally the domain of building occupants. So an area that would pose a health or safety risk for people with a disability. So probably stairs. Once again, any other ideas?
No, sorry, I just had a question in regards to that actually.
Yeah.
So if there's in the event of an emergency, you're not supposed to use the lifts.
No.
Now, what happens in that case with a disabled person?
Yeah, exactly.
How do they get out? You have to crawl out on their, on the ground.
Well, and
run.
What's that?
No, a run.
No, we'll see. So this goes back to, once again, the National Construction Code being the absolute base standard for which we build, and what it doesn't do is set out, this is how people with disabled access, well, who have a disability, should exit a building in an emergency. That is not catered for. So the way that they have to do that is wait for emergency services or the assistance of other people. Our policy here with the TAFE and our emergency evacuation is if there are people with disabilities and there is an emergency evacuation, they are not to use the lifts. And also, I guess, and this comes from health and safety or other health and safety aspects, other students aren't to help them down. They're meant to wait for security at the top of the stairs, and security will take them down. So that's something that we have within this building, and we have security personnel to assist with that. Certainly in this case, in a residence, in a private residence, yes, there's no accommodation for that, and yes, we can only assume that they either crawl down, like pull themselves down the stairs, or they wait for the fireys to arrive. Because you're not supposed to use a lift.
That's right.
But then also you're not supposed to use a chairlift in emergency.
Power can go out again.
Exactly, power can go out again as well. So apart from actually having some form of ramp for emergency exit, which might work well in emergencies, but should not be used in any other scenario, because I think for your disabled access ramps, your rise is 1 metre rise in 20 metres of run. To get up that 3 metres, that means we'll need 60 metres of run for a ramp to meet that. You can't even you won't be able to meet that within the confines of that site. So unfortunately this is one aspect that's not catered for by the National Construction Code to make that possible. Also, and any path of travel providing access only to an area exempted by A or B. So what we do not have to do is we don't have to provide disabled access to any of those areas in our building. So if we have an area which is dedicated solely to a staircase, then we don't have to provide disabled access to that staircase or to the path of travel that leads only to that staircase. But going down through table 3.1, if we get to our class 2, from a pedestrian entrance required to be accessible to at least one floor containing sole occupancy units, and to the entrance doorway of each sole occupancy unit located on that level. So that means that we do have to provide disabled access to every single sole occupancy unit on that level being the only level that we have for occupancy in this building, being level 1.
So every ability access.
Yes. Yeah.
So every has to have a front door that's wide enough for a wheelchair to go through, basically.
Yes. Yeah. Front door wide enough for a wheelchair, and also circulation space around that doorway, suitable as well.
For turning.
For turning.
You have to move a door 250 mil. That's going to require demolition. Do you mark that as demolition?
Yeah. Because we're demolishing some aspects of this building, so in that same demolition plan, demolish all those aspects of the building for and so it is getting very involved in terms of this building and what's required. However, those front, so from looking at the structure of the building, those front walls, well, for access to those units they're not load-bearing walls. So that should be fairly easy to do. So going on that's our access requirements for disabled access. So we've covered disabled car parking and the size of those, and then our car parking considerations in general. We've just covered our required exits from the building and worked out that we'll need those 2 exits. What we also need to do now is think about, okay, so now we have to have those 2 exits. How do we go about designing staircases to suit? And so for emergency exit, we're going to have fire isolated stairways. So stairway or ramp that is required to be a fire resisting shaft should be constructed of non-combustible materials, and so that if there is a local failure, it will not cause structural damage to or impair the fire resistance of the shaft. So but that should be fairly simple for us to meet. And then going further down, when we go designing stairs in accordance with the National Construction Code, we have to consider all of these aspects. So goings and rises. Goings is the length of a step, and the riser is how high that step goes up. So in this diagram here, we can see that is the length of our step, and the riser is how much that step goes up. Has everybody had some introduction previously to stair design? Yes?
Yeah, we have some in compliance.
Yeah. Okay. So, yeah. So you can move me on a bit quicker if you wish. But there is that slope relationship. But then also there is the requirement of not more than 18 rises in each flight. So a flight of stairs, that's a continuous flight of stairs that we're using those steps until we meet a landing. So if we look at the stairs out here, out the window, we have not more than 18 rises.
How long was the rise? What was the maximum rise?
Maximum riser for public is 190.
Generally 180. Normally, I've built a million stairs, we normally go to about 180. You don't ever go with what maximum.
So 3.4 is the maximum height we'd be able to achieve with 18 stairs at their maximum height.
Yep. Yep.
So we're under that because our first floor is 3 metres from the ground. So
yes. So we've got.
It just needs to be a single row of stairs. Doesn't need a platform midway or anything like that.
Yep. Doesn't necessarily, but it also depends on how much space and your car park layout and where your lift is going to go and how you configure your disabled access to your lift as well. So yeah, but that's right. You can do it in one flight. But our stairways have a slope relationship as well. So going and riser, 2 risers plus the going have to be in accordance with table D 2.13. So this is the table here. So we're looking at public stairways. Now our maximum riser is 190, and our minimum going is 250. So so our steepest possible stair, so 2 rises, so 2 lots of 190, so we're at 380, plus 1 going, so 580, so 630. That fits within our slope relationship there. So so the maximum, so 2R plus G, the maximum is 700, the minimum is 550 there. So typically when you're going to be designing a staircase, you're going to be looking at the steepest possible stair, because we want to be taking up the absolute minimum amount of space for our staircase in our design. So we've established, yes, we can meet. So using our our steepest riser, we can meet that, and then under our 18, and we can also meet easily our steepest possible stair in this scenario. So that's where I'd be looking at. I'd be going, okay, so 3 meters divided by 190. How many stairs is that? I'll probably get an odd number. So then, because I can't have 17.5 stairs, I'll have to go to 18. So then it'll be like 3 meters divided by 18. Now that's only an example. It's not going to be exactly those numbers. That's how we go designing our steepest staircase. But beyond that, then we have constraints around the length and the width of landings. So that's our stair. So we're looking at, so predominantly we're going to be looking at doing our steepest possible stair, because we're squeezed for space and we need to minimize the space taken up. Then we have to have a look at our landings. So landings having a maximum gradient of 1:50 may be used in any building to limit the number of risers in each flight and each landing. So this gradient, that's something you're probably not going to have to consider. Why would we put a gradient on a landing?
So that water can fall off of
it. Yeah. So that's only if it's an external staircase. So for internally, it's all enclosed, because we're enclosing several sides of our building. We don't need to be worried about that. So, but each landing must be not less than 750 millimeters long, and where this involves a change in direction, the length is measured 500 meters from the inside edge of the landing, and have non-slip resistance as a strip at the edge of the landing. So that's so that landing is not less than 750 long. Also, another thing to mention as well with the stairway design is that you can use winders as well. And does everybody know what winders are in a staircase? Is it Ryan Conquer? You know what winders are? Mary? Okay. I don't have a diagram here that shows what winders are, but they are the steps whereby they're angled steps for changing a direction. So if I can have a staircase that makes a right-hand turn. Now, one option is to put a landing in there. So these are my steps going up there. I've put a landing in here to change direction, or I can put 3 steps in lieu of that landing, and those are called winders. So that also helps me be more efficient with the use of space for that.
You can do that in the Class 2 building, can you?
What's that?
You can do that in the Class 2 building, can you?
Actually, I'm not sure about that.
I know in a residential you can, but I'm not
Yeah.
sure about Class 2, because
What
you have
about the
multiple
width?
users.
What about the width
Right.
of the one width?
Width,
Is that
yeah.
any requirement?
So there are required, so not more than 3 winders in lieu of a quarter landing. So it stems from your minimum width of your staircase and the going that you've chosen for your stairs. But that is a really good point as to whether you can. I don't know about that, whether you can have have winders in a Class 2 building. So we'll have to have a look, see where it would cover that.
I would think that they would be non-compliant in Class 2 buildings up there or whatever.
Yeah, no. Well, so we can click on this required, and that will take us to required means required to satisfy performance requirements or deemed to satisfy provisions of the BCA as appropriate. But we are required to have 2 emergency exits in this building. Therefore, these are required stairways. So in the case of required stairways, no winders in lieu of a landing. So yeah, so we're not going to be looking at winders for this project either, because these are required staircases.
Oh, you silly man.
Okay. So having briefly touched on our space requirements there for stairs, and then working through the possibilities for stairs, now we have to think about our accommodation for space for disabled access. So we've got that's going to be done through Design for Access and Mobility, or AS 1428.1 from 2009. We'll scoot down to our list of sections. So first thing that stands out to me is continuous accessible paths of travel, because what we're going to have to look for, this. So with our planning documentation, we have to sort out all of these design aspects that relate to the structure and where everything is going to go within the structure. And so we're thinking about all of our space constraints. So things about signage, tactile ground surface indicators, etc., are not going to be important to us so much at this point in planning, because these are all things that can be addressed at a later stage and addressed through our notation. But what is going to be important to us are things that have any spatial relationship with the building. So continuous, yeah.
Question
Yeah.
in regards to compliance. When there's a toilet, there's supposed to be 2 doorways between a toilet and a food prep area. And this is showing a toilet that goes straight out to the kitchen.
Right. Yeah. Okay.
So how do you get around that? I mean, yeah.
Yeah. Actually,
You're supposed to be able to shut 2 doors between a kitchen and a toilet. Or there's got to be a minimum distance other than that. But yeah.
Yeah.
That is what-
Okay. So yeah, I'm going to have a look at that.
Maybe the word kitchen's loosely. Maybe it's a kitchenette.
Kitchenette. But even still,
Okay.
there's,
Yeah, well, I suppose it's food preparation, really, isn't it?
Yeah, that's
Okay,
their only
yeah.
source of food preparation.
Yeah,
Yeah.
That
that
No, I'll,
makes heaps of sense.
yeah. No, I'll mark that down for something we'll have to explore at a later point, because obviously I didn't prepare for that
That's
at,
okay.
at all. Yeah, no, that's a really interesting point,
Yeah.
but maybe that only applies to class 1 buildings and not class 2.
Okay.
I stay in a lot of hotels where the kitchenette is just in the middle of the room.
But that's not,
Yes,
the
but that's-
hotels are
Yeah, a
not
whole
food
different
prep.
thing, yeah.
They're not designed for food preparation
That's a good
hotels.
point.
Yeah.
Whereas this is residence. This is
Yeah,
somebody's
right.
house. So therefore, I would think the same compliance would apply for residents.
Yeah, yeah. But then I've seen plenty of bed sit scenario, and now I guess these are buildings which are built possibly before changes in the NCC, that are single room then then a bathroom which is an enclosed room. Yeah, okay. We'll look into that. I'll have a look into that. So first of all, we're going to have a look at continuous accessible paths of travel. And then doors, doorways, and circulation space at doorways is another one that stands out to me. And then sanitary compartment for people with ambulant disabilities. So those are the 3 aspects that stand out to me.
The bathrooms have already been drawn, correct?
Okay.
No, they haven't.
Well,
Oh.
you can have
No.
overlapping.
The shower and the basin don't comply. Because the shower has to have a very large area. You can put a toilet and a shower and they can share space.
Yeah, but the circulation space can overlap.
Not with the way the basin is, I don't believe.
Yeah. All right. Well, so we'll get into that.
I think the only place you can't overlap is the exclusion zone around the can.
I've worked in the disability industry. There's no way you could shower a person who's in a wheelchair with a basin right there. There's no way.
Yeah.
Because you need to be able to access the side of that person for cleaning their back.
Yeah. But then that might be getting to that thing of NCC being the base
Yeah,
standard.
I'm sure that
of-
actually is non-compliant. I'm sure
Right.
of it.
Okay. Yeah. Cool. So continuous accessible paths of travel. Continuous accessible path of travel should not include a step, stairway, turnstile, revolving door, escalator, moving walk, or other impediment. So minimum of unobstructed height of a continuous accessible path of travel should be 2 meters or 1980 at doorways. So our doorways should comply with that.
Yeah,
That's fine. There's probably going to be rarely a scenario where that's going to be an issue. Width of continuous accessible path of travel, there might be an issue with that. So unless otherwise specified, such as doors, curved ramps and similar, the minimum obstructed width of a continuous accessible path of travel should be 1 metre, and the following should not intrude on the minimum unobstructed width of a continuous accessible path of travel. Fixtures and fittings, essential fixtures such as fire hose reels, fire extinguishers and switchboards, and door handles less than 900 millimeters above the finished floor level. So yeah, clear spaces. So we have to allow that 1 meter width, and that should not be an issue. Passing space for wheelchairs. Passing space for 2 persons using wheelchairs shall be a minimum width of 1800 for a minimum length of 2 meters. So where we have to have any passing spaces, and so consider that all of our units, because we have disabled access to our first floor, all of our single occupancy units have to have disabled access. So these are our passing spaces for wheelchairs. So minimum width of 1800, minimum length of 2 meters. And then if we've got any right angle turns in a restricted space in our dwelling, which I don't think we will have, well, not a significantly restricted space. So here we have, so corridor less than 1500 millimeters wide requires widening at turn. Corridor less than 1500 millimeters wide, once again, requires widening at turn for our 2 different scenarios, for right angle and for 75 degrees, and then for 60 degrees in a path of travel. Probably not going to be an issue for us in our building, but be aware that if you're going to have any corridors less than 1500, then you will have to ensure that your corners are beveled in accordance with this. Also, this may be a consideration. Space required for a wheelchair to make a 90 degree to 180 degree turn shall be not less than 2070 in the direction of travel and not less than 1540 wide as shown.
Was that AS?
Oh, sorry, this is AS 1428.1. So for our space, so we don't have any enclosed corridors, but what we do have, we have a space in front of our units, which acts as a path of travel. So then doorways and door circulation space at doorways. So go to page 56. So doorways, doors and circulation space at doorways. So luminance contrast. So that's in regards to the colour of your surfaces to make them stand out. That's not a spatial requirement for us, so we're not particularly concerned with that at this point in time. But things like clear openings of doorways may be an issue for us. So the minimum clear opening of a doorway on a continuous accessible path of travel should be 850 millimetres when measured from face to face of the open door to the doorstop. So 850 millimetres. So your standard 820 door is not going to be large enough. So we'll have to have a larger door, like so a 920.
All the
or
doors
so.
in the building are a metre.
They're
Yeah, they're
all 1 metre
wide.
already.
Yeah, they're
Yep.
plenty big enough, yeah.
So that's not going to be an
No.
issue for us. Circulation spaces at doorways on a continuous accessible path of travel. Circulation spaces shall be provided at every doorway, gate, or similar entryway on a continuous accessible path of travel. Circulation spaces at doorways shall have a gradient and crossfall no steeper than 1 in 40. We're not going to have any gradients to ours. Actually, we'll possibly we're going to have a gradient in of that balcony area at our entry to all of our doors, but that's going to be 1 in 50 to allow water to run off. So and so this is saying doorway circulation spaces shall be used in combination to allow access through doorways in both directions, as shown in figures 31 and 32. So here are our requirements for access to doors. So we can think about our, and I encourage you to go through this individually, but what you would most likely notice is that where we have, and this one's a good example of it, where we have access from either direction to a doorway, we have to have this width of free space on either side of the door. So we're coming down the corridor to make a right turn into this door. We need to have 660 millimeters on this side and 560 millimeters on that side. But if we are entering this door from straight on, then we only have to have 510 millimeters of clear space on this side of the door and no clear space on that side of the door. That's where the door is opening away from the user, by the way. But the point I want to illustrate is that our requirements for clear space are less if we can approach that door from front on. But what enables us to include that as an approach from front on as opposed to side on is the length of space that we have here. So here we don't have any length. That's going to be our minimum 1 meter, because our clear path of travel is our minimum is 1 meter, so we don't have any other specified length. This one here, we've got a length of, so if it's 850, that's our minimum. Well, the length is 1450 for all of these anyhow. So if we have a space that's 1450 millimeters from the face of a door to any obstruction, 1450 or greater, that means we can classify that as a front approach door. So then being a front approach door, that minimizes our requirement for space either side. And then when we have a door opening toward a user, that differs slightly. So we've got 530 this side, but then on that side we've got 110 millimeters. So what may be of a consideration to you is to think about your door swings, but probably the most important consideration is this length from the wall to any other obstruction behind.
I just have asked for a handle to be pushed back out of the way, the door to be opened a bit further.
Yeah. But in terms of design and allocating space for these things and modifying doors, that's probably going to be the most important thing for you to look at, is that clear space behind, to see if it's possible for us to do or to classify as a front approach door. Then other very important thing to have a look at is sanitary compartment. So go on to page 90. Oh, so it's sanitary facilities, page 68. Alright. Go to. So an important consideration are toilet clearances. So how close a clearance, or what are our distances for the toilet to the wall, and also beware that so many things in the National Construction Code are about minimum. So it has to be minimum this distance, minimum that. When it comes to layout of bathrooms for disabled access, there are also maximums as well. So be aware of any of these maximum dimensions.
Is that the toilet only for adults? I mean, there's some kids' toilet is very low and small.
Yeah. This is for adults.
For adults.
Yeah. I don't know of any requirements for toilets for kids. I haven't touched on that.
They should
on
do.
children. Yeah, there should be.
Because when you've got a kid that's sort of going by himself now,
Yes.
and he's not high enough to reach the toilet, and they're not, like my boys can't stand and pee without having a hand up, so urinal's out of the question.
Yes. Yeah.
Often his little fella sits on the the toilet, and yet, so I've got to sit in there with him standing on my feet.
Yeah. Or you get those little steps for them to.
Oh, not at home. I'm talking about when we're out. Like
yes,
we're doing a shopping centre, and the only toilets they got are really high.
The disabled toilets are higher again usually too.
They are. They're higher.
Yeah.
Is that to make it easier to slide off of the wheelchair?
I believe so.
Okay, that makes sense then.
Yeah, and also also easier for standing up with a walking frame as well, for a frame. So top of seat 460 to 480 millimeters. So toilet seats should be provided to accessible toilets, and yeah. So these go in your notes, but a backrest shall be provided on accessible toilets. So possibly to include, so you should include that in your drawings. So the backrest shall be capable of withstanding. So you're not going to have to design for the force. You install a backrest which is compliant, but have a height at the lower edge of the backrest to the top of the toilet seat of 120 to 150 millimeters. And the front edge of the centre of the backrest be positioned to achieve an angle of between 95 degrees and 100 degrees back from the seat hinge. So there's the diagram here for design of the backrest, and I think we've got a cross section through in the next one here. So that's our cross section with all of our dimensions. So these are what's going to be. These two examples are going to be what's important to you in your drawing up and design of the toilet. So top of seat 460 to 480, and then 120 to 150 millimeters to the base of your backrest.
If you could copy that image and paste it onto your plan.
Yeah.
Yeah, or whether there's was it a Revit family? Was it?
Yeah,
You
there's
call it a
family?
There's
Don't
Revit
have.
family with it, but I'm not sure what it looks like in 3-dimensional yet.
Yeah.
But I don't know if the Revit family has disability or accessible gear.
Yeah, it does.
It does?
Yeah, it's got maybe not to the extent of all the backrests and that being drawn in, but it's got a little bit of stuff in there.
Yeah.
I can try and get a section of it now, see what it looks like.
And so there are required zones for flushing control. So where the
Yeah, it
and
doesn't have the backrest or anything drawn in there,
Yeah, it didn't use it.
or a handrail.
And it might not be at the right height either.
No.
It's a standard toilet.
It's just, I think it's just a toilet with it, and they've got this clearance space marked around it and
Yep.
the exclusion zone.
Yep.
So you have to edit the family, I'd say.
and also be aware there's a zone for positioning of toilet paper dispenser as well. So for our flush there's a zone, and for toilet paper dispenser there is a zone, and then grab rails. So where a concealed or high-level cistern or flush valve is used, a continuous grab rail as specified in clause 17 shall be provided across the rear wall and side wall nearest the toilet pan, as shown in figure 42. So we have locations of our and dimensions for grab rails. And then general positions of grab rails in toilets. Okay, and then this is probably going to be the handiest diagram for you in the Australian standard. So it sets out your locations. Now, I'm sure all of you are smart enough, but just in case for some that might miss it, we don't require 3 hand basins in our bathroom. So they're put in there to provide options for locations of hand basins and how that interacts. But also be aware this that is the circulation space for toilet alone. What we're going to be dealing with ours is an entire bathroom, and I'll flip down to that one
So
now.
when you split the room and you remove, if you make the other room a laundry and take the washing machine and the dryer out of your bathroom and put it in the other room, you don't need that second sink, do you?
No, you don't need the trough.
So you can just remove that altogether. That gives you a bit more space for your clearances.
I think.
Yes,
Yeah,
yeah.
you went.
Yeah,
Does that
so I'll record
include
that.
door circulation space?
Once your door's open, it's all open space anyway.
Okay.
So as long as you can pull a wheelchair up there, open the door, back up to open the door, then you're all clear. So that's how. So that actually encroaches over the zone, the toilet door, the swing of the door does.
Yeah.
Yes.
When it's open, it doesn't encroach, and when it closes, it doesn't encroach.
Yeah.
And so this is our whole of layout. So yeah, as you're mentioning, you've got that 1400 millimeters exclusion zone from the edge of your pan out, but then those spaces can be shared. So what we won't have is a hob to our shower. So we'll have a flat floor. So this can be circulation space, but then we'll have a slope back to our floor trap in our shower. So, however, this seat can't be in our exclusion zone, obviously, for our access around the toilet. So this is going to be probably a very handy diagram for you in terms of the design of the bathroom for that. But these set out the minimums. So so typically, so typically through here we have minimum, but beware of any of the things that relate specifically to either toilets or showers where it says maximum distance, because we might end up having a space in our unit which is larger in one dimension than this, because we might not build it exactly the same as this. So then in those cases, beware of any of the maximum dimensions shown in there. So that's on page 87. So that's for our whole of bathroom.
So I noticed that the shower area has the curtain.
Yes.
You can't use the glass.
No, you cannot use a glass door. So you can't have any obstructions within that space, because we need to gain access for 1400 millimeters around this toilet here. So we can't have any obstruction to that space. So we have a curtain instead.
A lot of people with disabilities require assisted showering. So therefore you have to have the client, often in their wheelchairs, with a staff member actually in that zone, and that's why it has to be such a big zone.
Makes sense.
And also finally, in regards to your cross section and those shared spaces. So for our grades to shower, to bathroom and shower floors, we've got a bathroom area, 1 in 80 to 1 in 100 fall, but then to our shower waste outlet to our shower area, a 1 in 60, or between 1 in 60 and 1 in 80 fall for our shower area. And then finally the layouts for our shower area. So this is also going to be important to you, particularly in your cross section, but also in your plan. So we have heights and locations of grab rails, and then also the location and size of the folding seat. So the folding seat 390 to 400 millimeters. And
Not all of them have seats in them either.
What's that?
A lot of them don't actually have the seats in them.
Right. Okay.
Because the seats just get in the way of the wheelchairs. A lot of them don't have the seats.
Right. So even, yeah. Oh, so this, yeah, maybe that's something to check. So whether a seat is required, or this is
Suggested.
if you have a seat, then these are the dimensions of that seat.
Yeah, because the houses that I've worked in, and
Yes.
I'm still employed doing that job.
Yeah.
They're government built houses, where we have 5 clients in a house, and maybe one of the bathrooms might have a seat, the rest of them won't.
Right.
I'd
Okay.
like a seat in the shower. That'd be alright.
Yeah.
Have a sit down.
Yeah.
Read.
So because a lot of the bathrooms that we deal with have clients that actually aren't even in a wheelchair to shower.
Yeah.
They're actually in a shower bath. So they're actually, it's a bed.
Yes.
That we lay the client in.
Yes.
And bath them in this, and it's all just, yeah, they have some amazing equipment.
Great that for those at home. So in regards to the folding seat in the shower, so a foldable sheet shall be provided inside the shower recess as shown in figures 47 and 48. So that's a seat has to be included. Yeah, better read that again. So for our recording, so we're in part E 3.6 of the National Construction Code. In an accessible building, every passenger lift must be one of the types identified in this table E 3.6A, subject to the limitations on use specified in the table. So if it's an electric passenger lift or a hydraulic passenger lift, so certainly no limitations. Yeah, hang on. So this part, I had written down here minimum size 1100 by 1400.
Yeah, third one down on that column there.
Yeah, right. Okay. So lift. Yeah. So yeah, lift floor dimensions of not less than 1100 millimeters wide by 1400 millimeters deep for all lifts which travel not more than 12 meters, except. So for lifts that travel more than 12 meters, then 1400 by 1600. But when we're only go up one floor, so
That's not compliant anyway, though.
what's that?
That's not those measurements aren't compliant with an accessible lift.
Well, there's nothing, to my knowledge, there's nothing
If you
saying
go up,
you can't back out
okay.
of a lift with a wheelchair.
There is. It's in this. I'll show you on the NCC.
Right.
Is
It's
it?
in the performance provisions before all this starts. Keep going up. It's EP something or other.
Up the top there, there's a performance requirements.
It's EP.
EP 3.1.
So
Yeah, it's one of those two. EP, if you find where the EPs are, it's one of the. Yeah, click on that.
yeah, but what? Yeah, okay, I will. But this sort of runs to how the National Construction Code works. Is that there are deemed to satisfy provisions. So if it meets these aspects, then it's deemed to satisfy. Or you can also design something in accordance with the performance requirements. So E. So we'll have a look at this 3.1 to 3.4.
When a passenger lift is provided in a building required to be accessible, it must be suitable to be used by people with a disability. So if you can't turn around in it, it's not suitable.
But
Right,
you don't have
okay.
to be able to turn around though. You can
You
reverse
can't,
out.
you can't expect them to reverse out of an elevator.
Yeah. Okay. So this
It
does.
even says it goes into it on the Coney thing as well.
Yeah.
That it's to the 90th percentile of something or other.
Yeah.
But from what I've read, that's not. It's got to be at least allowed to be able to make a 60 to 90 degree turn to be able to get out.
Yeah, but we can also have a lift with a door on one side and a door on the other side. So it opens up at one side at the ground and then opens up on the other side at the next level. So that caters for, so there's no requirement to turn around. But basically what this cuts to though is what we're required to do. So what we're required to do for this is find out the minimum requirements. So the absolute minimum requirements, and those minimum requirements, they're set out by what the council says we have to do for the site and the design of the building, etc. But then it's set out by the National Construction Code, and the National Construction Code allows two approaches. One approach is to follow the code to the letter. So we go through the deemed to satisfy path, and it says you can do this, you can do this, you can do this. Or if we're not going to do something, if we're not going to follow the National Construction Code to the letter for the deemed to satisfy, we can engineer another solution, and that has to be engineered by an engineer which is certified in that particular field. But we can design or engineer a solution that meets those performance requirements. So if we were to find an alternative solution, then we would have to design a lift which is usable by accessible people. So we have to meet those performance requirements. Or we can go by the deemed to satisfy. And the deemed to satisfy is this path. So for passenger lifts in an accessible building, must be 1400 wide by 1400 wide, 1100 wide by 1400 deep. That's our minimum requirements. So we can do that. Now whether that is essentially usable or not by a person with a disability, that's for the Australian Building Codes Board to wear, and that's for them to make that determination on it. They've already made that determination within the latest copy of the NCC to say, if you do it this way, then it complies, and that's what we were required to do. But that is, the National Construction Code sets the base standard, and we
If you
can.
think about it, when they have to load